Hi, this is Sean from EC369, Group 6. We recently did a presentation on the socket programming portion, or the project that we did, and one of the feedback we got from Dr. Liu was that we never went over any code. Now, when we did that consciously. The reason we did that was because we generally feel that presentations that involve people going over code or just large slides of code are extremely boring. So we avoided doing that, and we decided to not include it, but we did get some feedback that that wasn't necessarily a good thing, and looking back, we do understand why. With a framework like Qt, people really have no concept of what we actually did and the kind of work we went to. So I'm gonna go over 2 of these 6 applications or 7 applications that we wrote, and basically go in depth on what they do and how they work with Qt. The first thing to know about Qt is that it uses its own IDE. You can tie it into Visual Studio, as I did in the previous video. It's kind of a pain though. The only reason I did it was for debugging. Qt can be gotten from the Qt project, or qt-project.org, and you go to Downloads, and there's a couple options. It's the first area. You can do it for Linux, Mac, or Windows. I personally did it for Windows. I did the 32-bit Visual Studio 2010, and basically that uses the compiler that's included with your Visual Studio 2010. I probably would not recommend doing that again. I would use the MinGW, the Minimalist GNU, because it includes a copy of the GCC compiler, which is slightly faster than the Visual Studio one. And it also helped a lot when we were installing on computers that didn't have Visual Studio. I was lucky my desktop did, but MinGW works on ones that doesn't exist. MinGW is actually the one I'm including in the final hand-in. I'm including this installer so that Dr. Liu can actually compile and run our code, so verify that we're not making stuff up here. So Qt Creator is installed. Like I said, I have the one that runs Visual Studio, but it doesn't really matter right now. It creates a project. When you create a project, you have this .pro file that is created that tells you what sources are included, what header files are included, and if there were forms for GUI stuff, it would be here. This one does not have a GUI, as you can see by Qt, the macro Qt minus equals GUI. GUI module is not included in this project because this is a server. There's no reason to have a GUI on your server. It doesn't do anything but do server stuff. We've added in the core, which is all the basic features of Qt, like the different containers it has, the different types of integers and string classes it has, and we've added in the network module, so obviously we can do networking stuff. A Qt program, like any C++ program, starts in the main. You call a Qt application and you pass it the argc and argv parameters. The name of the class for Qt core application does not matter, and you return that .exec, which basically says take that Qt application and do exactly what exec did in the operating system class we had. Replace the executable code that you are running for the main with the a.exec. I've also done these declarations in here. You would usually do in here if you had a GUI, like showing your main window in here, or calling any functions that you need. I do literally everything right here. These 2 lines do the entire server operations. First thing it does is start a server. That's a class called myServer that we wrote. And it inherits the TCP Server class. The inheritance part is extremely important. Without it, we wouldn't be able to do some of the stuff. Sorry, that was my phone. Anyway, so with the start server method, it creates a timer and some mutexes, which are basically semaphores that don't allow counting. It's just a single person can be using it at a time. And it starts the server with a listen command. We're using any address on the computer we're on, port 8060. That was the one defined by Dr. Liu. When that port receives an incoming connection, it passes to a new thread, right? The new thread, it passes the lock, basically the mutex. It passes a couple parameters for shared data, and it also passes the socket descriptor. That's the operating system's way of keeping track of which socket and port that is over. We use connects a lot. Now, connects allow, with Qt, asynchronous handling of certain things. With most languages, like C and C++ without any frameworks, if you want to do something when a variable changes, you have to be checking that variable all the time. Did it change yet? Nope. Did it change yet? Nope. Did it change yet? That wastes a lot of cycles. What we do in Qt is connect. So we connect one object to another object, and the objects emit and handle signals. So with Qt, the actual easiest example to show you is right here. Um, we do the timer is the sending class, the sending object, and its signal, right, is timeout. So when the timer expires, in this case it's 5 minutes, when 5 minutes expires, it sends a signal that is received by this object, that's the my server instance, because it's this, that's the keyword this in C++, and the slot that handles it, or the method that handles it, is cleanup. So it goes down to the cleanup method. And in this case, when the timer expires every 5 minutes, the server looks through the shared data and figures out any data that is no longer needed and removes it. That way we don't waste a bunch of RAM. Now, as you can see, it calls the my thread. It creates a thread for every single person that is on the server, which is what you need to do with TCP, because you need to have a stateful connection. You can't hold a connection with more than one person if you only have one thread. So mythread.cpp is where we handle all of that. Mythread.cpp is where we spend most of our time, and you can tell by old code that is just commented out. It's been completely just removed because we found it either didn't work or caused too many issues. We had to simplify. This first thing we do is we inherit Qthread with this one instead of TCP Server. Qthread allows us to do a lot of the threading things. When you do Qt and when you do a thread in Qt, you have to do a start method, and that start method automatically ties to run. So you override the run method. That's basically not the constructor, but it's the part right after the constructor that sets up the thread. And at the end of it, we run this exec command, which means that in the context of a thread in Qt, means that it will stay alive even after this scope has gone out. If you didn't have this, then when this scope of this method ran out, when it finished all the instructions that are on the screen and got down to here, all this stuff would be destroyed, which we don't want. We want it to continue to run and continue to listen for signals. Basically, all this does is it sets up the socket descriptor and starts a thread for it. If it can't start that up, it just cancels. It returns the thread to nothing. It basically just cancels the thread out. This handles a bunch of signals. It handles a ready read signal, which means the socket has data on it and is ready to be read. It handles a disconnected signal, so when the socket becomes disconnected. It handles a timeout signal to a timeout method, and then it handles a ready write signal, ready write slot. So what we end up doing is reading in commands in this. So the client will send a command that is unforeseen to the user or unseen to the user. Reg, which is a C++ client registering on the server. Reg.j. Brandon wrote a Java client. The J was just simply so he could parse things a little differently. We can still use if Brandon was a little more apt in Java, or I was a little more apt in Java, or any of the other groupmates was a little more apt in Java, we probably wouldn't need this separate area for Java, but oh well. Message, when a text message comes through, or the newest one. Oh no, I actually removed that. This is the older version. So message is where if there's a message, in the last video I showed you message 1, which was when a picture is being sent, but we don't have that in this version. All this old stuff is here for when it didn't work. We had a much more complex connection or message sending, but we removed all that. And basically just handles everything from here. There's no magic to it. A lot of these other classes like thread frame and frame data are parts of the shared memory, so they're not really important. User is not important for what I'm showing you. The two main important things were the server and the thread. It's a pretty simple thing to handle once you do it. Like I said, it took us quite a while to actually be able to get it to work correctly, but we finally did, and it works really well. I'm going to end this video, and I will show the UDP in just a moment.